Part B is slightly more tricky because here, instead of just x squared, we have e to the power of x. But the idea is the same. Again, I'm gonna focus on the square root part, try to simplify it and do substitution first, and then we'll deal with the whole integral next. First, I'm gonna rewrite the square root in the form that we can identify what my a and my heart is. So this 25 is basically 5 squared minus e to the x whole thing square, and compare with the expression we're familiar with, which is a square minus heart square. I can identify that my a is 5 here and my heart is e to the power of x here. Once we know that well from before, even from the conceptual video and last example, we're quite familiar with this expression, and we remember that my heart, I should set it up as a either sine theta or a cosine theta. It's up to you. So last one, I believe I set it up as sine, so this time we'll do it slightly different because I want to show you both ways. So let's do it as cosine. So my heart here is e to the x. Let's set it as a, which is 5 cosine theta instead of sine. Then take derivative. My ex dx is gonna be negative 5 sine theta d theta. Okay, and if we do that, I can rewrite the original as square root of 5 square minus 5 square cosine theta square. Oh, by the way, we'll do theta restriction later. I'll move this here and decide what to do with it later. Although I know I need to set up as sine, but I want to show you later. So that's gonna be 5 square times 1 minus cosine theta square, which is square root of 5 sine theta square. And this is the absolute value of 5 sine theta. And I wanna pick theta such that sine theta is positive. So again, we can draw it. Actually, I'm gonna reorder it a little bit so the logic is more, is better. So let's set it before we start simplifying substitution. So I can add my theta, need to be in certain intervals. So again, cast rule. For sine theta to be positive, I know that it's here, so that's 0 to pi. 0 to pi. Okay, so I can get rid of the absolute value. Simple, so that's gonna be fine sine theta, because my theta is in 0 to pi. And in this region, my sine theta is positive, or non-negative. Alright, and now I can go back to my integral and rewrite my integral as an integral of theta. So let's copy it down first. 25 minus e to the 2x dx. So before I know that e to the x dx equals to this. So the whole e to the x dx can be replaced using this part. And my square root part becomes 5. So I have 5 sine theta. This is coming from the square root part. Use a different color. So this is being replaced by this because we showed that they are equal to each other when I use substitution. And then ex dx becomes negative 5 sine theta d theta. Okay, and now we can do some simplification and use my trig identities. So 5 times negative 5 is negative 25. Let's leave it outside. And inside I have sine theta square and then d theta. So this is basically back to trigonometric integral. I don't know if you guys remember. There is a trig identity. So let me write it here. Recall that by trig identity, sine theta square can be rewritten as 1 over 2, 1 minus cosine 2 theta. And we can replace that so that I can evaluate my integral. So negative 25 times 1 over 2, 1 minus cosine 2 theta. d theta. Okay, and I can move this 1 over 2 out. That's gonna be negative 25 over 2. 1 minus cosine 2 theta d theta. And this one is easy to evaluate, so I continue here. So that's gonna be negative 25 over 2. This 1 becomes theta, and then negative cosine 2 theta becomes negative sine 2 theta, and then plus a constant. Sorry, and over 2. Forgot one part. 1 over 2 here. Alright, and finally, we need to rewrite this part as x. Okay, as x. So this part, need to put it back. So go back to the original. I need to know what's sine 2x basically. I have what? I have this. I have cosine theta equals to, so let me rewrite it. Actually, I'll start here again. So we know that e to the x equals to 5 times cosine theta, which means 1 over 5 e to the x equals to cosine theta. Or I can rewrite it as e to the x over 5. Maybe that's easier for you later. So, oops, that's wrong. So this is basically your last semester's material. So given one of them, so given, let's say, cosine theta or sine theta, tangent theta, you are required to know how to find the others. So because of that, we will use what we know from before. So you can either use a special triangle to figure out what it is, or you can use trig identity. So there are two ways to find sine theta. So sine 2 theta, which equals to, because of trig identity, we know that's 2 sine theta cosine theta. So eventually you still need to look for this. So there are two ways. One is you can use trig identity, because we know that my sine theta square equals to 1 minus cosine theta square. So using this you can figure it out, so we can give it a try. So that means my sine theta square equals to 1 minus e to the x over 5 square. Right? Yeah, so that's gonna be 1 minus, below is 25 e to the 2x. In other words, you would have 25 minus e to the 2x over 25. Looks kind of complicated, but that's okay. And then my sine x is gonna be what is it? It's gonna be square root of that. So square root of 25 minus e to the 2x. And using this, we can figure it out. Sine 2x, that's gonna be 2 times 1 over 5 square root of 25 minus e to the 2x, and times cosine theta, which is 1 over 5 e to the x. So this whole thing is 2 over 25 e to the x times square root of 25 minus e to the 2x. And you can replace it back. So, oops, that's gonna be, continue here, negative 25 over 2 theta. Oh, I still need to find theta, sorry, there's one more. Okay, so let's continue here, theta. So if I know this, then I know theta, because theta is just gonna be arc cosine of e to the x over 5. Okay, so now I can plug it back in. So arc cosine e to the x over 5, and then minus 1 over 2 times my sine 2 theta. So the 1 over 2 and 2 over 25 will cancel, so 1 over 25 here, and then e to the x square root of 25 minus e to the 2x plus c. Of course, you can simplify it even more. I'll talk about the second way later. So you can simplify it even more. Sorry, this is probably a little bit confusing. So that's gonna be negative 25 over 2 arc cosine e to the x over 5, and then plus, those two cancel out, so 1 over 2 e to the x times square root of 25 minus e to the 2x, and then plus c. That's one way of doing it. Just making sure it's alright. And the other way to find my sine 2x is using special triangle. Special triangle. That is, start with this, I know cosine theta, so we can draw a triangle. Right triangle, of course. Oops, this is not right triangle. And let's call this theta. I know cosine theta is e to the x over 5, so I can set it as e to the x over 5, and in that case this length is gonna be square root of 25 minus e to the 2x. In that case, I can figure out my sine immediately. So sine theta is gonna be this over this, so that's gonna be 1 over 5 square root of 25 minus e to the 2x. And we don't need to bother with the sign because before we already assumed that my theta is in this region where my sine theta is positive, so this is good. So that's a different way to figure out what your sine is, and you do the same way to figure out what's your sine to theta.